Hello. Today, let me walk you through combination sum 2. Okay, first, start stopwatch 20 minutes. This problem is similar to combination sum 1, but a bit different. Different point is the candidates contain duplicate elements, and we can't return duplicates combinations. So we have to return unique combinations. And each element from candidates may be chosen at most once within a combination. Okay, let's start. You can image interviewer. So I'd like to some question. Does candidates contain duplicates integer? Yes. Are candidates sorted? No. If candidates are empty, what should we return? No. Candidates ranks starting at 1. So empty candidates is impossible. Okay. If we are impossible to make any combinations, what should we return? For example, candidates 2. Candidates is 2, only 2, and target equal 5. What should we do? You should return the empty array. Okay. If we are impossible to make any combination, for example, candidate is only 2, target is 5. What should we do? Return empty array. Okay, happy path is example 1 and example 2, like this. And edge case is candidate equal this is edge case. Okay, what is constraints? Just to confirm, do we have any constraints or restrictions? Yeah, constraints is starting at 1 to 100 candidates ranks, and the candidates element is starting at 1 until 50, and target is starting at 1 until 30. Okay, let's think about Prune. So move on X corridor. Let's think about this example. Candidate is 1, 5, 1, 4, and target 7. This is not sorted. First, if we try brute force approach, we have to decide between two choices, take or not. the decision tree is like that. First choice is index 0, 1. We take or not. First subset is 1, empty. And next value is 5. So we take 5 or not. We take 5 or not. Like this. And next index. We continue this. Finally, we have a lot of results combinations. This is brute force approach. Okay. First idea is sorting. If we sort it, candidates is 1, 1, 4, 5, and target 7. First choice is 1. This is 1. And take 1 or not to take is empty. And second choice is index. This is change color. I'd like to change color. This is index 0. And next, this is index 1. And this is take. This is not to take. And next, this is index 1's element 1. And this. You can see earlier this and this. So we can find that we can cut the branch, cut the same result. Prune. It's called prune. Prune equal cut or remove. Cut or remove branch. So we can find this is similar. This reaches similar result. So 1 4 1 4 and 1 4 5 1 4 5. So this is duplicate. So we want to remove this branch. This is duplicate result, duplicate. So sorting is very useful for us. And second idea is backtracking. So first, we take 1 or not to take, and we can find we can skip the same element because if we take the same element, finally we reach the same result and the duplicate combinations. So we skip We skip subsequent identical elements. We skip uh, we skip index 1, index 0, index 0 and index 1 because this is the same number 1 and index 2 is 4, so we move on this. So we take 4 or not, and we take 5 or not. Look at here. Left subtree. Left subtree is look like same of brute force tree. But the right subtree is very simple and very slim. Very small. So we can cut the branch. So this is pruning. Okay. So we can use sorting and backtracking. And with brute force approach, time complexity is 2 to the 2 to the power of n because we have to choice between two choices, take or not. And how many times is this? The number of the ranks of candidates. So 2 to the power of n time complexity. To avoid duplicate efficiently, we'll use backtracking and sorting. Okay, let's jump into the code. Wait a minute. This is a combination sum 1. The combination sum 2 is okay. First, we have to sort candidates. Candidates dot sort. And of course, we have to prepare result array. And do you remember backtracking is a specific type of DFS? So define DFS function and what should we pass input as an argument? Index I and current subset and total is sum of current subset. What is the base case? If total equal target. We add result to current subset copy. Because Python subset is reference copy. So, and return. And if first total is greater than target and or index is greater or equal length of candidates out of range, return. Okay, this is an ending case. And next, let's think about take. This is DFS backtracking, mainly point take or not to take. Take or not to take. Take. Take is current subset dot we add candidates index I, and of course we move on next index, so I plus 1 and current subset, and we add total plus candidates I. And how about not to take? This is this problem point. Current dot pop. This is because this is backtracking, and current pop, and we want to skip the subsequent identical element. So while I index I no, index candidates I equal candidates I plus 1, and if we use I plus 1 in the loop, of course we ensure I is not out of range. I is so yeah, I plus 1 equal less than length of candidates. In this loop, incremental, and when end the loop, okay, let's think about example. Example I 1 1 4 5. I equal 0 while condition is candidate candidate 0, candidate 0 equal candidate 1. So this, and the 1 less than ranks. Sorry. So one more 5 minutes. Okay, let's speed up. While condition is candidate 0 equal 1. Yes, true. And 1 is less than length of candidate, so length of candidate is 4, so it's true. True. So increment. And next, I equal 1. While condition is candidate 1 equal candidate 2. Not true. False. It is false. So end the loop. And then we want to, so I or I plus 1, which total is same and current is same, and then we want to move on next index, because now index 1 this, and we want to move on next index, so element 4 so I plus 1. Okay, last DFS we call 0 empty and 0, and return less. Let's review this. For example, for example, 1, 1, 2, and target 3. DFS 0, empty, total equals 0, so current append candidates 0, so 1. DFS DFS 1 current total plus candidates I. So DFS 1 current subset is 1, total and plus candidates I equal 1. 1, 1, 1 is not base case. So next, current append 1, and 2, 1, 1, 2. 2, 1, 1, 2. And next, base case is this is over the ranks of candidates, so return. Next, 1, 1, 2 is time limit. Let's wrap up. Okay. Time comp. Stop. Time complexity is big. Time complexity is big O 2 to the power of n. And times n. Because we choose two options. And how many times should we choose? This is n times. And we copy. We current copy this. So this takes n time. So linear time. So time complexity is worst case 2 to the time of n times n. And it's the same result against brute force or more worse. But however, in practice, this pruning and pruning the branch makes it significantly faster because we can avoid some duplicates result like this. And space complexity is big O linear time n. Why? Because recursion stack and the current combination list. Because this height is maximum n. Why? Because we move on one index each step. One index each step. One index each step. Each step. Each step. So maximum height is n equal length of candidates. So space complexity is big O n. Combination sum and combination sum 2 is very impressive problem. So I would like to review again and again and watch this video again and again. So thank you watching today. See you by later. I forgot to run this code and I tried once, but make error, occurred error. List index out of range, candidates I plus 1, and I plus 1 greater, less than, how to solve this? All accepted. This order is essential. Because I plus 1 is of out of index. If out of index, this is error. This causes error, but this is ensure that I plus 1 is less than length of candidates, so we it is impossible to over the out of index. Submit. Finish. Thank you for watching today.